Let's get it. I do a daily today. Oh my goodness. Bits, binary. Is this a binary problem? Okay, looks like an array, so I think we're fine. Bro, my laptop is kind of slow. Okay. We have two special characters. The first character can be represented by a zero, by a 1-bit zero. The second character can be represented by 2 bits, 1-0 or 1-1. Given a binary array bits that ends with 0, return true if the character must be a 1. If the last character the only way to decode it is 2-bit character and a 1-bit character. Oh, okay. Like group it. So the last character is 1-bit character. Okay, group and group. Oh, the only way to decode it is there. Hold on. Let me. I have a question. Basically, it's just like, can I pair them up together? Okay, so 1 1. One, 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 one. Okay, that's because it's even. Okay, what if it's 5? Still like, there's 2, 2, 2. Okay, so why can I say return if the length of bits is equal to mod 2 equals 0 and bits of 0, or I guess the last one. Well, I guess it will always be guaranteed, so yeah, let's just try that. This is odd, so that's true. Okay, so inverse it. Bro, imagine. Okay, that makes sense. Let me see why though. Okay, okay, I see the problem. You can only group them if they're 1-0 or 1-1. I can't group a 0-0. Okay, makes sense. Okay, so I need to actually see the thing. So first thing is, can I do one thing? So first thing is, let me just do a 2-pointer. We have L for R in range. We'll do 1 to there. Bits of R. Oops. Bits of R. Brother. Bits of L. Okay. So we to compare. Okay. Wait, so basically I want a 1 or 2. I don't want to sum. Wait, so that's 2, 2, 1. That's false. Oh, that's fine. That's fine. Yeah. Let me see the ranges. So this would be true. So these would be with 2. We get a 2 here. We get a. I can't do these. I have to do these 2. Oh, shit. Oh, no. I'm getting all the pairs wrong. Okay, I get it now. I need to figure out all the pairs. So these are a pair, and these are a pair. These are a pair, and then this is by itself. Then I'm gonna add them up. Okay, I have an idea. Okay. Do you have a better way to do this? Wait, I kind of have an idea. This is true because the length of 1 equals 2. Wait, so this is, if I add all these up, this is just 1 and the size is 3, and then this is just false because the size is 3. No, I can't do that. Okay. Just get like, I think it's just basically the size plus like, if I group everything up, is there, okay, yeah, I need to iterate correctly. Let's just try that. Iterate like this, so, okay, I'll do it by 2's then. I'll just do it for r in range of length of bits starting at 1, right? And then I need to move I think I need to iterate by like 2 or something, bro. Like, okay, I start here. This is 1 plus 2 is 3, so 0, 1, 2, 3. So do here. 0, 1, 2, 3. And then these and this. Okay. And then just the one before it, so yeah. L is r minus 1. And then we'll do bits of r minus 1, bits of r. Okay, so we basically say this and this, right? Then plus 2 is 0, 1, 2, 3 here, and this. Wait, it's these two, these, oh, this would be false, actually. This, that's fine. But this is true because, let me just do the, damn, this is a hard problem for easy. 1, 1, 1, okay. 1, 1, 1, 0. Okay, so 1, 1, 1, 1. 1, 1, 1, 0. 1, 1, 1, 0. So I start here, compare that to, plus 2 is here, because 1 plus 2 is 3, 0, 1, 2, 3, so we go here and here, and that's why it's false. Okay, never mind, I got it. So this is the right algorithm. So we do prev, cur, okay, the previous and the current, what do we do? If prev would say cur plus prev equals 1, or let's call sum. If val equals 1 or val equals 2. Something. We could do a flag here. Flag. false. No. If does not equal then return false. Return true. Damn, bro, my shit's slow. Wrong? Let me think about this logic here. This is true because we code this up. Oh, what am I doing, bro? That's true. If it doesn't, so it's actually, yeah, I kind of need a flag. Assume it's false. Return flag equals true, I guess. Else flag equals false again. I don't know, bro. That's weird. Okay, I don't know the... What am I trying to say? So, like, okay, I'm checking here. This is that, and then... I feel like the sum of the array has to do something. 1110. Okay. Okay, hold on. What am I doing? Why can I do this? Hold on. Let me cook. Why can I say, okay, if it's odd, like, hold on, what about this one? This was even, so it's probably, you can group them evenly. Okay, if it's even, then it's 100% false. If length of bits equals mod 2 equals return false. If it's odd, this is okay. If it's odd, then there's a chance of being true because you can have the nice thing here, right? Bits equals, okay, so return, right? So basically check if the bits of -1 plus bits of -2. This is a bad problem in my opinion. If that equals 1 or bits plus bits of 2 equals 2, return true, return. Does that work? It doesn't. Oh, okay. If the sum of the array, let me see something. If the sum of the array, okay, like if we say the size, okay, so we're just trying to group them, like we're trying to read them together. It could be a 2-bit or a 1-bit, right? We're always trying to read by 2. Right? We're trying to say, okay, 1. Let's assume that it takes this. Okay, Okay, for every value, take this plus 1. Take this plus 1. Or like, okay, take this plus, that's 2. Oh, yeah. This is a 1-bit, 2-bit, or this is a 2-bit. This is a 1-bit. The last character is not a 1-bit character. Given the array bits at the end, is there a return true if the last character must be a 1-bit character? So like I'm trying to combine these, right? This is a 2-bit and then this must be a 1-bit, so true. This is a 2-bit, 2-bit, 2-bit. So length of this is length of this. That's so how many total bits is this? 2, 2, 2. So that's equal to, or actually this is only 1-bit. Right? Oh, these are all 2-bits. This is equal to 6. 6 bits. But I don't know what I do here. So and then size of the list is okay. But this could be represented by 2 bits, then 1 bit. So this is 2. 1 bit. That's equal to 3. This is 4. I see the vision now. Okay, what is the total bits here? This could take up 2 bits. This could take up 2 bits. This could take up 2 bits. This could take up still 2 bits, right? I feel like the even oddness is probably true. Like maybe count the number of like ones here. So there's like odd number of ones, so there's an odd number of ones, so it's true true if there's an odd number of 11110. That's still odd though. This is tricky. I don't know what this is actually like. How like what this is really asking. Let's see. Oh wow. Increment pointer. That's it. When reading from the I position, if bits of I equals 0, the next character must be I plus 1 because 0 is a 1-bit. Else, if bits of I equals 1, the next character must be I plus 2 because 1 is only represented by 2-bit character. Oh, okay. Oh, okay. So I was on the somewhat track. So like, what is the sum of all the... Oh, okay. I get it now. I get it. Okay. So let's get the sum of the bits. So if it's a 1-bit, that's 2, right? If it's 0-bit, that's 1, 1. So that's equal. Well, actually, not yet. We don't know yet. And that's going to equal 3. Right? So that's 1 plus 1. Then that's that. Then that's 0. That's plus 1. Because it's represented by 1. The sum is going to be 3. Then what do they check here? If I is equal to length of bits minus 1. Wait, why do we check that? At the end, if our pointer is at bits, then the last character must have a size of... True. Okay. Oh, okay, yeah. Because the size of the thing is 3. But this is... Yeah. So... Oh, wait. We only go up to the second element. So... We only add... Okay. We add all the bits. So the 1 is going to be represented by 2. Right? 1 is equal... So 1 is... The second can be represented by 2 bits. 1, 0, 1. So 1s are represented by 1. Or... That's 2 bits, right? And then... 0s are represented by 1s. 1 bit. So that's a total of 3. These are the only 2 values we cover. The size of the list is 2, so 3 does not equal 2 though. Bits of I plus 1. This doesn't make sense to me at all. At the end, if our pointer is at bits dot length minus 1, then the last character must have a size of bit. That is 1 bit. I don't see how the... Oh, this is a pointer, not like the total. They do it to the last element. Oh, while I is less than length of bits. Oh. Okay. So it will stop right there as soon as we get this. And that'll be true. Oh, okay. This is saying I'll take up 2 bits and we move the pointer. Oh, okay. That's fucking smart. Okay, I get the idea now. So we'll start at 0 while I is length of bits minus 1, right? As long as we're 1 before the last one, calculate it, move the pointer by how many bits it'll take up. So since it's a 1, bits of I plus 1, right? Return I equals length of bits minus 1. Okay, that makes sense. Alright, see you guys tomorrow.